Yesterday we learned about our zero product property. Today we're going to learn how to use the zero product property in conjunction with a process that's called factoring. Okay, so remember that for the zero product property, we have two things that are being multiplied together, two factors that end up with a product of zero. And in order for this equation to be true, at least one of the factors has to actually equal zero, right? So we can set the factors equal to zero and solve for the x's that make that true. So if you missed that yesterday, you're going to want to make sure and watch that video. Okay, so the greatest common factor is the largest term that evenly divides an expression. So here the directions tell us to find the greatest common factor for each expression. So all we have to do is identify it. We don't have to do anything with it. We just have to find it. So we're going to do this in pieces. First, we're going to tackle the coefficients and constants. Those are the numbers in front of our variables or any numbers that are just by themselves. So what is the biggest number that evenly divides 4, 8, and 12? 2 is a factor, but is it the biggest? 4. 4 is what we're looking for. Okay? So now we're going to look at the x's. So here I have 2 x's multiplied together. In this term I have 3, and in this term I just have 1. So if I'm going to take away the same number of x's from each of my terms, because they get mad if I'm not fair, what is the biggest number that I can take away from all 3? Can I take away 3 from this one? I can only take away 1, because this one only has 1 for me to take. So whatever the smallest power is for the variable, that's how many I can take. Does that make sense? Okay. That's it. We're done. Okay. What is the biggest number that evenly divides both 28 and 14? Bigger than 7. 14. So our GCF has a 14 in it. What is the greatest power of 3 that I can take? 2, because I can't take 3 from the one that only has 2. So I can take out a power of 2 for the C's. Can I take D's from everybody? No, because this one doesn't have a D for me to take. So no D. All right, what about C? What is the biggest number that evenly divides both 3 and 15? 3. Oops, I forgot to write GCF. Okay, what power of X is in my GCF? Ooh, not 3. 2. Good recovery. What about for Y? What's the biggest power of Y for my GCF? 1. Okay, so that's how to find the GCF. Great. Now we're going to use that to learn how to factor. Now we know all sorts of inverse operations, right? Adding undoes subtracting, dividing undoes multiplying, right? We know about distribution, and now we're going to learn factoring, because factoring undoes distribution. If you had to pick one of our 4 operations, adding, subtracting, multiplying, or dividing, which of those does distribution do? Multiplying. So distribution, we multiply. So if this is multiplying, what do you think undoes it? Yeah, so in factoring, we're going to have to divide. Okay, just to refresh your memory, because it's been a minute, let's distribute up here. This is some Unit 2 stuff. So I do 3 times 5, and I get 15. V squared times v to the first. I add my powers, and I get v cubed, yes. Bring down my plus. 3v squared times 4 gives me 12, and I just keep my v squared the way it is. So that's my distributing. Now we're going to learn how to undo that and break those apart into two factors that multiply together to make that product. All right, here we go. Step 1, we have to find the GCF of the expression and write it outside of our parentheses. Okay, so leave a little bit of room under here because we're going to use that as our dividing workspace. We're going to write it way down here. So this will be our GCF. So what is the biggest number that evenly divides both 15 and 12? 3. Okay, what power of V can come out in my GCF? Good. Now, the next step says that I have to divide each term of my expression. That's the one I started with, by my GCF. Okay, so that's going to be up here. We're going to do that. So we're going to divide 15v cubed by 3v squared, and we're going to divide 12v squared by 3v squared. So the last thing says that we're going to simplify with the GCF out in front and the leftovers in parentheses. Okay, so 15 divided by 3 is 5. V cubed divided by v squared is v, right? Bring down my plus. 12 divided by 3 is 4. And what happens to my v squared? Cancel. Now, I want you to compare this to what we started with. What are they? They're the exact same. So we've been distributing for a long time, and now we're going to start learning how to undistribute by factoring. It's pretty cool. Okay, cool. Next. All right, now we're going to do it fast. All right, so get your parentheses, leave some space. Eventually, you'll be able to do the dividing step in your head, and you won't have to leave the space anymore. You can always show that step if you want to, but some of you are going to stop needing it. Okay, so what is the biggest number that evenly divides both 6 and 18? 6. What power of x can come out? 2, because I can't take 3. What about power of y? 1. Good. Okay, now we have to find the leftovers. So I'm going to divide both terms of my expression by 6x squared y. So 6 over 6, cancel, they make a 1. X cubed divided by x squared, just x. Y's, cancel, bring down the plus. 18 divided by 6, 3. X squared, cancel with a y.
Booyah.
Booyah. Okay, so that was part 1. What does part 2 say that we have to do?
Check your work.
Yep. We got to check our work by distributing. So this is part 2 down here. We just distribute. Boom, ba-boom. 6 times 1, 6. X squared times x. Add my powers. Keep the base. Oops, I wrote squared. It should be cubed. Nothing to add with the y power, so I just keep the y power the same. 6 times 3, positive 18. Keep my x squared. Y times y squared. Is it the same as what I started with?
Yes.
Check. We did it. Okay. The next one is on here because we have to talk about what to do if we have a negative leading coefficient. What did I forget? Oh, this one? There? Thank you. I forgot a 2 on here. Good catch. Okay, so get your GCF ready. Get your, oh, that wasn't enough space. GCF ready, parentheses, your GCF. So when your leading coefficient is negative, your GCF must be negative. Otherwise, you will be in a world of hurt. -7. Okay. What power of m comes out?
2.
Woo.
Or is it 1?
1. What about n? Also 1. Okay, now we find the leftovers. So we divide by -7mn. Be careful because we're dividing by a negative and that's going to change our signs. So a negative divided by a negative makes a +1. M squared divided by m, m. N's cancel. +14 divided by a -7 makes a -2. M over m, cancel. N squared divided by n, n. So just so you don't have to redo the whole thing, you can check your work really quick. Okay. So whatever started off negative when we divided out a negative GCF turned positive. And whatever was positive when we divided out a negative GCF turned negative. Do you see how they change signs? That's going to really help you check your work. All right, I'm preaching to the choir. So the next thing we have to do is check our work by distributing. Okay, -7 times 1, -7. M times m, m squared, keep the n. -7 times -2, +14, good. Keep the m. N times n, n squared. Check. Checkity check. So there should be no wondering, hey, did I do this right? Because you could always check your work. Even if the directions don't tell you to, you guys are so good at distributing at this point, like it takes you 5 seconds. Okay. So right now, this is just kind of like a neat parlor trick, right? But why would we ever want to do this?
The steps part?
Why would we want to factor? What is the point? So I want to show you a couple of problems. Okay, the first one I want to show you is this. It looks like this. 2x squared minus 4 equals 0. How would we attack that problem?
I would move the 4 over to the other side and make it a positive.
Yeah, we could move the 4 over and get 2x squared equals 4. We could divide by 2, and then we would end up taking the square root. So this one would be square root method. Okay? All right, now I'm going to put up another one here for you. What if I had 2x in front of x minus 6 equals 0? What would you do there?
I forget what it's called, but it's like you take the 2x equals 0 and then you take the 6.
Yeah, that's our ZPP.
Yeah.
So we would say 2x equals 0 and x minus 6 equals 0. Solve for x, get the curly brackets, ZPP. Okay, this one is ZPP. All right, so those are the two methods that we know so far. Does this look like either of those?
Yeah, the first one.
It kind of looks like the first one, but what's the difference?
It has an X.
Yeah, it's got that pesky x on there, that middle term. Okay? If you think about it in standard form, it's got a b value of -4. All right, so we can't use square root method on this. But if you think about what we just did today, do you see a factor? A greatest common factor?
Yeah.
What is it?
Yeah.
I see a 2. Okay, so let's get parentheses ready. Okay, what else can come out? What power of x? 1. Good. So if I divide that out, 2 divided by 2 gives us a 1. X squared divided by x gives us x. Bring down the negative. 4 divided by 2 is 2. X divided by x, cancel, equals 0. Now, which one does it look like?
The ZPP.
Yep. So we turned something that was unsolvable into something that was easily solvable by the ZPP just by factoring out a GCF. It's pretty sick. So our first step was factor out GCF. Our second step is going to be to use the ZPP, zero product property. So we will set our factors to 0. Okay, we will solve the baby equations. And then we will list our P and Q in curly brackets. And that's it. It's going to be fast. So here we go. 2x equals 0 and x minus 2 equals 0. Can you do this in your head? What times 2 is 0?
0.
0. Okay, can you do this one in your heads? What take away 2 is 0? Good. All right, curly brackets and we're done. Yeah, really. How do you like them apples?
No. I don't like them.
Kind of look like grapes.
Kind of look like grapes? How do you like them grapes? All right, let's try another one. When we're solving, what do we want the y value to be? 0, because we want the x-intercepts which have a y value of 0. Okay, so do you see a GCF?
Yeah, 6.
Okay, I see a 6. Can I take a power of x out? 1. X to the first can come out. Okay, now what's left? 6 divided by 6 is 1. X squared divided by x is x. Bring down the plus. 24 divided by 6 is 4. X divided by x, cancel. Now I'm ready for my ZPP. I do 6x equals 0. X plus 4 equals 0. What times 6 is 0?
0.
Yeah. What plus 4 is 0? Good. Write them in curly brackets. Because that's it. Okay, the next one is a little bit weird looking. What is it missing? What do we have here that we don't have there?
0.
A 0. So how are we going to get rid of the 7x and turn it into a 0?
Subtract the 2.
Okay, I heard two really good ideas. I want to address the divide first. Okay, so I'm going to explain this way better than my teacher in high school ever did. Sorry if you were my teacher in high school. So can you, in your head, divide with me? If I divide both of these by 7x, I would get 2x equals 1. Are you guys with me? Okay. So if I solve this for x, I get x equals 1 divided by 2, right? Do you remember that this is a vertical line because it's an x equals equation?
Yeah.
Good. So this is a vertical line that crosses the x-axis at 1/2. Do you see that it can only cross in one place? This only has one solution. Okay, how many solutions do I have to let a parabola have? 2. I have to allow for the possibility that it has 2 solutions. It won't always. Sometimes it'll just hit the axis and bounce off, but I have to let it if it wants to. Yes. Yeah. So the problem with dividing both sides by 7x is that we lose one of our beautiful solution possibilities. So we're not allowed to divide both sides by x. We can divide both sides, listen to me, we can divide both sides by 7, but we can't divide both sides by the x. That is strictly prohibited. Okay, thank you. All right, so instead we're going to take the other suggestion, which is to subtract 7x from both sides. So we'll have 14x squared minus 7x equals 0. So that solves two problems. One, it gives us a 0 instead of a 1, and we get to keep the quadratic instead of turning it into a line. Cool? Okay. So now do we have a GCF? What is it? 7 with an x. Good. What's the leftovers? 14 divided by 7 is 2. What power of x stays? Just x, right? 1x.
Mm-hmm.
Okay. Negative 7x divided by 7x gives us a negative 1. Okay, now we're ready for the ZPP. Okay, so 7x equals 0 and 2x minus 1 equals 0. Divide both sides by 7 and we get x equals 0. Remember, we can divide by the 7 on both sides, just not the x. Okay, what about if we add 1 to both sides? We get 2x equals 1. Divide both sides by 2, we get x equals 1/2. We knew we were going to get 1/2, right? That's the one we got this way. but the one that we lost was this, right?
Yeah.
Okay, so we have to make sure we get them both. So our x's are 0 and 1/2. Okay, we're not going to do the last 4, but we do have to talk about what's in the banner. The method that we have been practicing on the back page is solving by a method called factoring. Okay, part of factoring is using the ZPP. So in order to solve by factoring, what does one side of our equation have to be? 0. Because we can't use the ZPP until we've got that 0. Otherwise, what good are my factors?
No good.
No good. Okay, that's the end of the notes.